Hello, everyone. How are we all doing today? I'm sure we are all doing great. It's nice to actually be here once again to present this lovely session to you all. I'm sure you all are all expectant of this particular session. And trust me, yeah, I'm also expectant, and I know it's going to be an interesting session. In fact, the topic of today is one of the topics I have been looking forward to. And yes, I am sure you have been looking forward to the topic of today as well. Um, Before I go ahead to introduce the speaker to you, I just want to let you know that we have an interesting community, and we will love for you all to follow us on our social media channels, and also keep yourself updated with programs we're going to be scheduling for you all throughout the year. So you can go on our LinkedIn page to follow us. You can subscribe on our YouTube channel. You can as well follow on our Twitter channel as well. And yes, we are here to serve you all the hot Microsoft trainings. All right, so I'm going to proceed now to introduce the speaker for today. He is none other than our global leader, or let me just say, our regional leader for Nigeria. He heads the MCT for the Microsoft um, certified trainers, right? He's our regional leader for the MCTs. Also, he's one of our leaders which we have in the Azure community. So he's going to be taking us on the beautiful, interesting topic for today, and I'm sure that you all are willing to learn. So I'll be bringing him on stage now, and I'll be having with him a little chat before we proceed on the session for today. All right, let me bring him in. Yes, Sashayi, how are you doing today?
I'm great.
That's
I'm
great.
fine. Yeah.
That's great.
Although
So,
the topic is somehow, as you said, is something that many people are running away to dive in, but
but I
is
mean,
is yeah.
that's one of the reasons we have you as our leader, right? So if everyone is running away to dive in, you as the leader will be able to dive in, and then give us the full gist of the content.
Okay, I will try my best and ensure that we all are the present uh, study since we are capture audience are for beginners. So
All right.
hopefully give you what's and how you look at database in the light of information I'm going to pass to you.
That's great. That's great. All right. You've just given us a wonderful hint on what the topic is going to be about. So at this point, I'm just going to let you do your thing. Give us this, and I'm going to take my pen and my paper and jot down while you actually teach us and train us for today. All right, Sashay, the floor is yours.
Okay. Thank you for, can you help me to push my slide? That's great. So today we're going to look at a topic which is something that is not far-reaching because it's something that has been there for a long time. What do I mean by that? The issue of data. So many quotes have said data is the oil of the nation today. Oil is even more important that when you have enough data, you'll be able to achieve more in terms of financial heights than even diamond gold that we have today, because we have seen several companies that within 2 years, they have arrived at the best company in terms of finance, and they are out there. For example, Facebook. Facebook came in a couple of years back, and before you know, the owner of Facebook was ranked among the leaders in terms of business status, in terms of financial status. And that means to us that data is as important as to every oil and gas industry, to every tea industry, to every company around us. Data is a very, very unique area that we cannot overemphasize. So today we're going to look at how we can actually store this data. And our pointer is to look at relational data. Now, from the term relation, what do we understand by relation? Relation can be, for example, who are my relation? If I ask any of you out there, you tell me my relation can be, if you are married, your wife. If you have kids, your kids, they are related to you. Now, how do you now put this on the scale of generation? You know, you are now relating the first subject, which is me, to my generation. That means, who are my relatives? Now, my relatives can be from the first generation to the third generation to the fifth generation. Each of these are tied to one data, which is me. Now, we want to look at how we can actually play around with this data that merges up not just as a single entity, but as a data can be scaled in several dimensions to ensure that each individual are tied together, and you can use that as a resolving report to be able to understand the flow of the data, the flow of the information, and the ability to get details and inference from such data. So today, we're going to look at, since we're just looking at the beginner, we are going to look at several aspects of it. The first aspect we're going to look at is data storage. How do I store it? Then we are going to look at a unique data storage that is very good for relational data, which is called SQL database. But our concern here is a cloud version, which is Azure SQL database. Now, we know this particular topic can be got from, it takes about 25 to 30% of, if you are writing AZ305, that means it's an advanced course for database. But our streamline this evening is to look at people that are just getting into data science, getting into Azure data space. So we might not be taking the high level we have here, but we're going to simplify it for people that are trying to get into other space, a data space, in order to see the future we have in Azure. So we're going to look at SQL database. We're going to look at how do I increase my input in terms of data flow. How do I scale this out? Then we're going to go further to look at recommendation we have there and how to design it. We might not go into design of the SQL Edge, which is more of the new trend. Now, let me just give you an historical background. Now, the way data reside now, data was primarily when IT was still in the infantry level. most of the data are secured through a perimeter, which we do through a firewall, through our security features. All those things were meant to cater for our data that's within the flow of our domain. But as advancement increased, as internet increased, as we now injected the cloud technology as a means of having high compute, now it brought us to a point by which you might look outward. Now we notice that the telecom industry brought in some mobile phone that are smart in nature, mobile phone that can run as a computer. Now that brought us to the point at which data can not only be constrained by our firewall, data is going outside. Data is now transiting from the basic level, from the basic point of view, more transiting anywhere, everywhere, by any means. Now, at that point, we now need to look at ways by which you can curtail such data. One of those data is the injection of IoT. What is IoT? IoT is the Internet of Things. Internet of Things. Now, what is Internet of Things? Internet of Things is saying we have some devices that are out there that are smart in nature. For example, industries, they have machinery that produce for them. But how do they interact? How do they communicate with engineers that are actually in Australia when they are in Nigeria? What are ways can we communicate with them? They need to have an interface. And those interface is where the IoT comes in, where you can actually use devices that are smart and integrate it with computing ability. And those ability will allow you to be able to interact with it, will allow you to be able to work with it. And we're also going to look at two demos. The first demo is how to create a storage account. And the second demo is how to even create an Azure SQL Server. Because as I said, our focus is basically for those that are beginners. So let's go right at what we have today. My name is Oluwaseyi Oluwawunmiju. I'm a consultant at Covenant Technology. I happen to be an MVP and MCT for Nigeria, and also I work in consulting firm for quite a while now, at least running to 20 years, 19 plus. So I'll be taking you to this dive, and as I said earlier, technology is about the people. Now, if you look at the diagraphy of all this picture now, you notice one unique thing that is very, very, very familiar. Each of them are using a device, and each of those devices are not constrained from the pharmaceutical industry, as you can see from the upper left, down to the upper right, someone in his office, down to someone in a consulting firm, down to somebody in aviation or oil and gas, down to someone that is running refinery, down to someone that is actually looking at some industrial application like an IoT application. Each of them sorry for that. Each of them has a unique feature, and that feature is about data. Data has come to stay. Data is everywhere. The data is a means by which we can actually advance technology, advance our future, get proper information. And those information is what ideally is used for several demography, inference, several information in terms of AI, in terms of machine learning. All these are comprised. But this data, what are these data? So we know that technology is about us. And I can tell you, the world has changed. What we know when it comes to data is more of data that's seated in our well, they are relational data, but they are seated in our on-prem environment. They are seated in a single server. They are seated somewhere that we can actually manage by ourselves. But data now has gone beyond that, and that's where the revolving change has come in. Data is now moving not just as a single entity, but as a service. And for each service, we are saying that how do I tap into the elasticity of data? How do I tap into the power that comes with the cloud computing? So the changing world brings us to a divergence here, where we have a new way to run a database, a relational database, and an old way which reside on our on-prem, and how do we interact with this our database. All these are what we're going to look at, but mind you, our focus will be on the new way. Now, let's go right into the first topic, design of data storage. Design of data storage. Now, when we talk of design, what comes to your mind is an IT feature that brings about ability to get certain structure, skeletal structure built into infrastructure, and those infrastructure built into services, and those services built into application, and those applications now go down to users as a way they interact with those applications. Now, the cloud technology, as I made from my intro, is something that we cannot take out of the equation in the recent time. Just as I've established that we have the new way and the old way. And the new way is actually built on the cloud environment. Now, we want to relate with database as a service. We want to get our speed. If we are building an application, we want to store your data in a very secure manner, in a timely manner, in a place by which can you quickly get access, irrespective of where you are today, where you are calling from. I can see people calling from every part of the world. The question is, calling in through this interface shows us that the world has become a global village, and for industries and for industries practitioners, what you'll be looking at is, how do I manage the system? How do I ensure that I am properly managing my services and ensuring that my users are getting it in the long run? Now, I also want to know that as I run these services, it can be geo-replicated. It's not structured to be in one guide, one place. And also be in tune to ensure that whenever I want to scale up or scale down, I should be able to create something like a secondary database in the matter of time and few minutes, and it's on. That business continuity, ability to have availability, ability to scale our database are things that come to industry now. How do I do that? And that brings us to trying to look at each of these data in their own raw form. Now, I'll give a pause here. In those days, what we know as data is something that is actually built on a structure. And those structure, I can use Excel as a simple form of this structure, where you have data that has a column and a row. A column and a row. And what that means is that for every data input, it is associated with the information and the data. Now, with time, this scale up to what? Several dimensions, where you can have data that is now relational to several other data from several other databases. And what the database does is to ensure that their relation is outputted as information. And such data are referred to as structured data. They are referred to as structured data. Now, structured data are data that are relational in nature, and it can be shared as a service. It has the capability of dimensionalizing itself across each of the data. Oh, someone said they can't hear me. Please, can you guys hear me? Promise, can you hear me? Hello, Promise. Can you hear me? Can you guys hear me? Okay, thank you. Thank you, Solomon. Thank you, Daniel. So please, I think it's Coca that said he cannot hear me. Maybe you should try and see whether there is something from your side. So, okay, thank you, Solomon. And we're looking at structured data, and I made mention as a data that are properly structured, data that are relational in nature. That means I can dimensionalize it to several data and ensure that it can relate with them to inference certain information that I can get from one subject. I use myself as an example. I have a family, and such family can be related to my relative. Such relative can also be related above my fourth generation, third generation, such data like where they were born, their family trees. We can have that structure, and those structure can be stored in some database like SQL Server, which are actually built on relational capability. Now, we go to the semi-structured data. Now, the semi-structured data actually structured in its own way, but the format at which it's stored might differ. An example is a JSON file. Another example is your email. Another example is your CSV file. All those files are structured, and those structures are built on each application the way they relate with the content, which is different from what I said earlier, where you have a database that is usually with a column, as you can see here. And if you can see here from the diagram here, you can see here we have the column against the row. And we can see semi-structure as a data that runs across some application like XML, HTML, JSON file. All those files has their own capability. They're structured in their own ways, but they actually build on each individual application the way they relate with the data within its specification. Now, the unstructured data. Now, this is where the wow came in the data evolution. Now, people look at, for example, let me give you a typical social media environment like Facebook. Now, Facebook, the video, the audio, the pictures you post on Facebook are actually data. But those data are unstructured. They are just there. They're actually pulled into the environment for social connection. And each of those data are connecting with themselves in terms of history. But at the behind Facebook, there's a tool Facebook uses to monitor each individual, the name, the sex, the information being uploaded. Now, during the monitoring sequence, they have a semi-structured environment, maybe through a JSON file, maybe through an HTML file, or maybe through an XML file. each of okay. Tosin, please. Michael said the video is blur. Can we confirm from others? Is your own video blur too? Please, can you help me to confirm that? Okay, thank you, Tosin. Michael, maybe you should check your internet. Maybe there's something wrong with or something needs to be done. Sorry for that. It's clear from my side though. Although I'm the originator, I should see it clearly anyway, but it's clear from my side. But if it's not from your side, please, please, can you just try to initiate that? Probably you try to refresh your page, maybe to come better. Sorry for that. So we move on. Now let's go down to other things we can in terms of the main core here. An example of a relational database we're going to look at, which is the Azure SQL database. And for Azure SQL database, the first thing you need to know is that to have access to it, you must have an account on the Azure portal, and you can get a free one despite the fact, and that free one can enable you to have access to it, because the free one, when you have your credit card, you can actually plug in, and Microsoft gives you 200 USD for a month to be able to use that. So once I finish with this, I'll quickly do a simple demo where I'll show you from the Azure portal how to create an SQL database. Then we now move on. But before we do that, we'd like to look at some sequence which are necessary in terms of how do I use this Azure database. I'll just go through this before I take you to my demo environment. Now, for us and for everyone that is here, we should know that the Azure database is actually built on certain compute environments. Now, you can actually run your SQL database from a single virtual machine. Now, what is a virtual machine? Now, in computing age, we all know that computers are actually hardware, and each of these hardware has resolute features like memory, capability of a CPU, capability of a storage. Now, once you have that device, you might be able to do several computing operations on it. Now, the virtual environment is actually a software that is used to mimic the same environment you have in your hardware. So we can actually run SQL Server on a virtual machine, and you can run it on the expensive one, looking at the OS. You can also run it as an individual that want to manage the service and throw it out to people. Then we have other ways by which you can use Azure SQL database. One of the ways you can use it is through what we call lift and shift. Now, it brings us beyond just your virtual environment, whether it's on-prem or your physical environment, but it takes us to instances that are beyond physical, and it's trying to take us to places like the cloud technology. Now, in the cloud technology, it's running as database as a service. And one of the ways you can have access to it is to have instances by which you can use it. One of the instances is a single entity instance. Now, this is very when you say single entity, all the resources are bundled in one places, and you can actually manage the service from there. Then you have the pool instance. The pool instance is where you have multiple manageable, multiple instances across each database, across several zones, and you can fully manage the service through that. Now, the third way by which you can actually use Azure database is to use this as a database, not just as a managed instance. For example, managed instance for your application, you are running your web design, but you want to have it as a database that you can use as a service, or your company can use it to project their services across several entities of data that you use. One of those area you can use the modern cloud application who runs on a single database. Now, it's hyperscale. It can take up to 100 terabytes, and it can also run on the serverless computing. Now, serverless computing is where we are taking hardware outside just virtual environment. We are taking an environment that is enclosed with all services like the network, like the storage, everything compacted in one. They are serverless. They are things that you cannot inject with external hardware or external anything external to allow the operationality of that particular environment. So serverless give you a unique environment. It's the dawn of the day today. It's something that can actually help us to increase the way our services running on computing in future. So we also have the elastic pool. Now, this is where you have several databases matched together as a resource. And because of the performance and the management of such, it's easy for you to have multi-database and allow full managed service to run on it. So why we have stated that, let's just quickly have a pause here and try to go to our environment and see how we can actually see from the Azure portal how a database looks like. So I'm going to run my Azure environment. As I said, you must have your subscription. You must be able to have your Azure account for your tenant. So this is one I use for my demo called Sheyi Tokwe. So I'll go home now. And here I told you that for you to have, you can have the free one, which is $200. Actually, once you click on the free services, it takes you a guide, and that guide will eventually move you across each of these offerings, and you plug in your card, and Microsoft benevolently give you 200 USD to be able to use to run this application. This is how the free 12-month account looks like, and you just plug what you want to do. You can see from several packages you can run from there. Now, going back here, now we have the other way. If you're a student out there and you're listening to me, you can actually also have access to this Azure subscription by exploring the student area, where you can actually get direction on how you can plug in your student account. They'll build, you can start from free. And this one, you don't need to have a credit card mapped to it. You just need to go in there and have your free account. Now, stating that, let's go over. Now, I know you have seen a lot since the beginning. Now, Azure environment looks like, you can see from the tail, from the blade here, you can see each of the services. Now, we're going to look at all the resources we have here, and we're going to try to look at one called Azure SQL Server. I hope you can see, you can have Azure. Let's start with SQL Server. Now, this SQL database, where you can actually see a managed environment, and you can also see some variety of it. You can see the one you can use with Azure Arc. Azure Arc is actually SQL Server that is tied into an environment called hack. Now, just as I said earlier, the changing in terms of people desire, people have capability to move beyond just the on-prem environment to the point by which we want to introduce things like IoT and the rest. And we need to be conscious, because anything on internet is a call for security. And because of that, we have the Azure Arc that can stand in for you and protect your environment. You can see other things like Elastic Pool, where you have several managed environments and you want to do, and you can see the SQL virtual machine. Now, this is Azure providing you an environment where you can actually have your SQL server already mounted, already installed, already configured, with that needs some of details from you to build your SQL server. So let's go to SQL server. My God, I think it's not allowing me, so I have to change my subscription from that. I'll shift my account and try to look at my default one. So it moves me to my, you can see, you can have multiple subscription across your multiple environment in order to use Azure. So we just go right away. Okay, I still have money here. So I look at Azure SQL Server, database, good. I click on it. Now this is, I don't have any. Now, one trick about cloud technology, please, for beginners, once you have created or you create several applications, and endeavor to ensure that you delete it if it's not in use, especially if you are using it for a test scenario, because the more your subscription there keep depleting when you have those services on. So the first thing we need to do is to create an SQL server. So we have a plus here, which tells you that you can actually add a new SQL server, or you go to down here where you have no SQL server display and you can create. Any of it goes once you know you want to create one. So let's do on the upper side. You click on create. It takes you here. Now, from the basic, now, just as I said earlier, almost all Azure features or services require a subscription, which is tied to your tenant anyway. So now it's asking me which of my subscription. I have two of them. I choose the one I do. Then you need to have a resource group. Now, a resource group, what does that mean? A resource group is a categorization of, now, when I explain this, I don't know how many of you are from the western part of Nigeria. I'm going to use something that is similar. If you happen to live with a grandma, and that grandma always put on what we call, they call it a money bag. Now, those old women doesn't really, in those days, they don't really appreciate the banking system. They keep their money by their side. So they have this bag. Now, each of the bag, they put everything they want to use when they go anywhere. Is it the money? Is it the card? Is it the writing material? Everything is in that bag. And whenever you take that bag from them, you have taken everything from them. So also a resource group is where Azure try to categorize everything you need for a service, for any service. So maybe your networking capability, the ident, everything is there in a resource. So now I have some resource I have here. I have the one for class demo just. So let's just take this, or test demo. Now, once I have that, the next thing I need to create is to give my database a name. What do I call it? Azure Training. Now, your database cannot end with something. No, it's not ending with that, is it? Okay. Then I need to select the server. Which of the server do I want? I have to create one. Now, Creating one is where the next topic we're going to look how to get several services. I need to put the name of the database, we call it training, Azure training. Having the same issue. Okay, sorry, I used uppercase. Then it's already in use. One, good. Then location. Now this is where this one is used to. Okay, that's good. Then where is it located? Where am I getting my resource from? Since we're in Africa, usually I go for most time Europe, Western Europe, UK, Europe, or South Africa. But you can see everywhere you have will always tie your subscription to where you have capability and availability of that feature. Does not have access to pre-server from this region. So let's just leave it at the default for this demo, and let's see where it goes with that. So good, we have that authentication. Now authentication in Azure, it can either be for Azure's SQL Server, can either be your window authentication, which is referred to here because of the cloud offering called Azure AD, or you want to use SQL. That means building your credential from the server, your SQL server you have created. But let's just leave it at this and set your admin. So we need to set the admin, and we look at our admin here. Well, the group we want to do, let me just look for my name. Okay. Let me just use this. Okay, and select, and I click OK. Please remind me before I finish that I need to delete those things, please. And then the other things that comes in handy, can you see immediately I got it, it got me the costs. That's why I said I'm going to use estimated cost for a month is about $227. So you must be mindful of this. Before you deploy this, you must ensure that you actually have that intact, and that knowledge is very key. Then the other thing is to look at where you want your backup redundancy. Redundancy is key to every operation in our new world, because you need to have a way by which you have your database spread across certain region and ensure that if there's a failure at one plant, you'll be able to have access to your database from the other side. So you have to create redundancy, whether you want it to be localized or you have it through a zone or a geo. I always prefer geo because anything can happen in Africa, but cannot at the same time happen in Europe. Anything can happen in America, but will not happen in Asia. So each of these regions has a uniqueness, and it's better you spread it. So once you do that, you review it and you create it. So after you review, the next thing is to create. But because, as I said before, I don't want to eat into my subscription, I will just go to the previous and try to get it out of my system. Yeah. Please, if you have any question on this, just drop it while I go back to our slide. So now we have seen how we can actually get to Azure SQL Database. Let's deep dive a little more into scalability. Now, why do I need to scale? Now, every solution in the modern cloud-first environment is always with the quest of scaling. Now, what is scaling? Scaling is capability to increase your resource with time without affecting your user, without affecting your production. And everyone is built in the cloud environment to have this capability. Now, the scaling in Azure can either go for your database, go vertically, or you can bring it down. That means as you use your application, for example, maybe I need a database for an e-commerce environment. An e-commerce environment is an environment where I sell shoes. Now, I noticed from research that purchase of shoe increased in April, in Ramadan celebration, or any other celebration across the world, or in the Christmas. Let's use Christmas as a typical example. Across the world, everybody celebrates Christmas. Now, at that point, as a shoe manufacturer, what should I do? I should be able to have a system that have a database that once I get to the point when it's nearing Christmas, there should be ability where my resource increase. One, because there'll be high demand, there'll be high consumption, and people want to buy shoes for Christmas. Although I don't know if Christmas has been when we have this, for people in Nigeria and Africa, when we have this money scarce, I don't know how Christmas will have been. So that policy might not apply. But in real sense, scalability is ability to find scenario by which it can push forward your resources to allow each of them to be able to have access to what you want. And one of those solutions is when your SQL Server database is elastic. Now, from the word elastic is more of a way by which you create. Now, if you have ever seen a rubber band is something that you can stretch. And what that means is that I apparently have several SQL Server SQL database across my Azure offering, and I'm able to manage it in order to meet each resource requirement for my users across those databases. Now, another way you can scale is when you have a managed service. Now, as I mentioned earlier, a managed service is where you run to solution provider like Azure, you pay for the subscription. Now, whether you are using a single database, you can run your application and ensure that it can be usable by several users across several spectrum of location. Now, another way you can actually scale is by optimization. Although for this, you might have to look at your budget, ensure that your cost, because here, just as I showed you there, just that single database I'm trying to build per month, I'll be paying over $200 to use that SQL database. Now, if I don't have the capability to do that, then I need to scale down to processes that can easily work for me. Now, let's look at another aspect, which is availability. Now, availability in terms of the core here is that database has come to stay, because when we started this class, we saw that database is not just stationary anymore. Database is transitional now. It's something that goes from here. For example, I have an application that runs probably my accounting solution. I left office today, Saturday. I'm somewhere maybe in Ibadan, and by default, people in the office need some approval, and that approval tends to be something that's related to my service as a staff for that company. So what that entails is that I need to be able anywhere to run this application, approve whatever is approvable, and allow my application to work. So that means I need data, and that data can be from application. That application might be the accounting application. And because of that, that means I need to be able to ensure that the database required that tie me to that resource is available. So when you talk of availability, we are talking of replicating a database across several offerings. Maybe it's a multi-database or a single database, but the dynamic nature of making management possible is what we are looking at. So let's quickly look at how do we make this available. Now, we have two types of building availability in terms of pricing, and each of these also is tied to our resource and what we want to achieve. The first one is the DTU, and DTU is more related to the transaction that you are actually running on your database. Now, you can see from the graph here, let me bring my pointer, you can see here that you have your computing environment against the storage. And if you plot this against this, it's telling us for us to be able to buy into database, I must first of all look at my options. And those options tied to my performance in terms of the memory that I need, in terms of the ability to read the database and write it, and the CPU that is blended with it. So the database transactional unit, which is DTU, have the capability to give you pricing when it brings in your computing against what you want to use it for, maybe for storage, how volume of your storage, and that pricing is there. Now, the complexity of this is that most of this amount are fixed because of the storage that you have there, and probably if you are tied it to a certain period of time. Now, the other one is the VCall. Now, that also, you cannot erase the fact that you need to look at other things like the use against the resource too. Now, the VCall database is virtually tying to the logic. Now, the logic that's tie in your control, the capability of expanding, the capability of scaling, the capability of having those resources handy for use. So the characteristics of this is built on the hardware you are using. Now, the third way of pricing is a serverless. Now, I mentioned serverless as a capability that goes beyond just the hardware, even beyond the virtual environment. Serverless brings us close to a capability where you have an enclosure like a container, and each of these containers builds on everything you need in terms of how you use it. So the characteristics of this in terms of pricing is it is not consistent. It's unpredictable. You can use less today, you can use more tomorrow. And because it's more automated, your scaling, your computing is based on what you demand. So what I want you to take home with when you call of database, serverless database, and terms of pricing, is the ability to avoid operational overload, because it is set with a mechanism to sense what you want to do, plan for you. Then if you need upgrade, it's easy because the management of a serverless environment is actually built on what you demand at that time. So looking at how we can make things available, let's try and look further on some other capability that we can see in relational database, and that is high availability in terms of the tiers you want to run. I don't know if there's any question that we can quickly look at. Promise?
Yeah, currently at my end, no questions at the moment. I'm just following up with some of the attendants who were having some issues with their videos, but they've all
Okay.
confirmed that everything is clear and the video is actually streaming clear and working fine now.
Okay, that's
So
great.
at this point, I feel like you can go on, and then I'll keep asking them for questions, and those who drop their questions by the end of your session, I'll ask so that you can give them answers.
Okay, that's great. So
All right.
we're going
Thank
to
you.
look at how we can tie in now several of these in terms of the availability. Now, when I talk of high availability, we are saying we want our services to be designed with a workload that can easily be used. Now, we have several types of this model. We have the general purpose service tier, and we have the standard available model. Each of these are tied to be able to give your service more of a better outlook in terms of what you budget for and how you deploy it. Now, it also helps you to span the way you can back up those files, whether through a local environment or through a read access geographical environment. And it also helps you to build more of this in terms of the instances you want to use. So the goal of generally to have high availability is to be able to guarantee that your database you can see from the design here, the ringing, the application ringing, ensure there's a failover in case. All this design is to ensure that that application at the extreme right, is capable of ensuring that your data are highly guaranteed for a 99.99% time uptime without worrying you when maintenance will be done or when there's any outage. So generally, that is just the essence. And there are several models. We have the standard availability, which is based on the computing and the storage. And we have the premium, which is based on the cluster of database engine processes you have to use. This is the premium one, based on generally on the engine you are using, the node. Most time, this is targeted as critical, mission critical, that's English, mission critical environment, where we know we want our database deployed to eventually always be on. And we want it to have higher performance. You can see from here, from the application, the availability must be always on. Yeah, and it has the secondary replica, it has a backup, and it ensures you can have it in several regions, whether zone, local, or geographical environments.
First, use face recognition to unlock the device.
So now let's look at strategy in terms of failover. Now, failover generally is when in those days when we are building, I remember there was a time there was this solution by one of the provider then, and what we wanted to do in my establishment then was to be able to have an uptime in terms of certain solution that a customer is using. And when we call for failover, we are not really looking at the backup sequence. We are looking at a way by which we can have our data and application running. And if there's any eventually, because we know that things can happen, under strike sometime, fire outbreak sometime, what other instance can we find? Several things across the world can actually cause anything to happen, failure. It can be for us in Africa, it can be power. And when you have frequent power failure, your database might be inconsistent. And because of that, we must now begin to look inward. How do I design a way by which I make my operational environment capable of keeping the same data that I'm rolling real time? So failover is more like an operation tied to a backup. Now, that backup data you can keep. You can see here, it's the design here. You can see how the failover is being designed here, where you have it as a primary. You have two databases here, primary and secondary, so that if anything happens, it also groups. So we have the primary region, the second region, and each of these can easily, once there's a failure, can move to the other one. So each of these failover is more, as I said, is a backup operation that automatically switch to another database that is already standing in waiting for it. Now, it also, in terms of its operation, look at the server, look at the network that actually work with the first one, and a replica of it will be done for the secondary. And instead of shutting down your service all over and trying to do that, you can do that. An example of such failover solution that was mentioned was Barracuda. And there was not another one that we ran then was AverNet, then where you can have it across several data center. But in Azure, we have two different types of failover region. We can have it as a use case for your own zone. If I take in US, for example, East US, then I have a failover of my secondary replica or my database in the US region. Then I can also have it across region. That means I have one in the US and have another one in Europe. Each of these implies that if there's a failover of or there's failure on any of my database, it can go to another region. So we move further to look at, to select several key points, which I'm going to emphasize on how we can check or get a failover in terms of auto failover, in terms of business critical instances, in terms of the pricing. So each of them can also help you to be able to target the way you want to run your design, especially when you want to look at the way you're operating your system. Now, for high availability, you have over 16 terabytes. You can also migrate, lift and ship your SQL Server from on-prem to cloud. You can look at the costs. You can also look at how you can deal with this in several cadre. Now, one aspect that we have mentioned earlier when I introduced this course is that anytime you are looking at cloud technology, you must not forget that you must look at the security aspect of it. Why do I need security? Because your data today are transitional. And each of these data is no more predominantly at rest. Each data now is cutting across several operational devices, is cutting across several web offering, is cutting across several users that are not localized in your environment. So I must be able to look out of the box. I need to now begin to look at my protection. How do I protect my data? How do I ensure that this data are not taken over? Because anything cloud is an emphasis for security. Now, there are several ways by which Microsoft approached this in terms of from the network. Now, for me, in terms of reverse proxy, I always feel every network, every defense area should take very, very important note on the aspect of identity and access. Because whether you like it or not, the front door to every security breach is from your identity. Although we can say the communication layer, which is the network layer, where you can have your data flow, can also pay very, very important price if you don't take care of it. That's why on terms of the network security, you must be able to create things that can protect. That's why Microsoft introduced what we call VNet. The rules of firewall has been in for ages. It's also implemented in the cloud where you have several group tied together, and you can also have what we call private link. That means this is a secure path that is only meant for certain particular people to have access to your database. Then just going back to identity. Sorry for that, it's my AI that's another aspect that we must pay attention to, which I mentioned earlier, is the identity, where the person that's going to use the database instance need to be authenticated. Microsoft has built in some Azure AD preference in terms of the SQL authentication, or use the Azure AD where you can secure it perfectly. And if you are running your database on an hybrid environment, then you need to also look at window authentication process. Then you must not forget that when you are building your identity and your protection, you must also build it on a role-based environment where you can control the access. And each of these roles must have the level of its own security so that you can really tie down every abnormality that comes to your data from the accessibility. Then other things you need to pay attention to is when those data leaves your confine, maybe the cloud, your tenant, how do you encrypt it? How do you ensure that encryption can go through tunnel like TLS? How you can actually mask those data to avoid unwanted hack that can come on your data when it leaves your environment. Finally, there should be monitoring environment, a monitoring system for SQL, your database. And one of them is that you can use for this monitoring exercise is advanced threat protection. You can actually audit your SQL Server to see who have access, where is those data moves, and how it comes about. You can also use what we call Microsoft Defender for cloud, and every other one that can, like the variability assessment, can help you to assess your environment, ensure that you are not entered and without any issue. Now, authentication. Now, authentication on SQL Server database can either be as AD, that means Azure AD. When it comes to directory system, we are talking of a compartment that has all the information to identify you, to look at your properties, and to ensure the permission that is required is tied to your name. So you can either go through the Azure already built in when you try to get into the tenant, or you can actually look at the one that the SQL Server has already built in itself because it has its own identity and authentication system, or you can have two of them mapped together in order of preference where the user is coming from. Now, I mentioned the edge earlier, and I strictly emphasize that Azure Edge injection was actually a way by which Microsoft look at other devices that are in our today environment. And one of those pointer is the IoT. And Microsoft has what it classify Internet of Things devices, where you can manage it from the edge, you can deploy it, and for instance, to be able to manage it across your container that runs other applications like Linux example, like an example. So how do you use it? It helps you to ensure that the data is properly organized across the spectrum of the IoT environment, and it also helps you to slow down breakage that can cause, internet is very key to this operational process. And to slow down that intermittently, it can help you to create like a convergence conveyor that can help you to connect. Then it can also help you to overcome any limitation. So apart from using SQL database as a relational environment for SQL Server, you can actually deploy it for things like the IoT. Just you can see from the design here, you can see the edgeway and the gateway. You can see the logic that is run. You can run it on basic business logic. You can run it on machine learning. And you can see the database that helps you to inject and ensure that those data can give you inference that can affect the operation generally. And you can see the hub to Azure Hub running on an operational database, whether it's a Cosmos DB or a Microsoft SQL database, or the one that is managed by Azure, which is referred to Azure SQL database. So let's look at Cosmos DB. What is Cosmos DB? Now, Cosmos DB is actually a managed environment that is built on no SQL, they call it no SQL environment, and it's relational in nature. So no SQL database, which is alias as not only SQL database, is more tabular in nature, not tabular rather in nature, and it helps to store data in different ways. And each of these ways help you to provide a model that can create flexibility of your data, and it can also help you to scale it. So going into that, let's look at how Cosmos DB can work here. Now, we are here now. Microsoft injected Azure Cosmos DB because of the internet or something relating to the online. Because whenever, I don't know whether you have any experience when you are buying a product online and you notice that the product is not coming up as you want, and I don't know how you feel. Some of us feel distracted. Some of us feel not happy. And especially when it comes to the web, you understand, and mobile environments, real-time selling and marketing. When we talk of people that play games, games has come to play. We need a database that can run on a modern app development. Now, the Cosmos DB is a sell out to developers, and each developer need. I hope everybody can hear me. Promise, are we still? Can you hear me? Hello? Can you?
Yes, we can.
Okay.
Yes, we
Okay.
can.
Thank you.
Yes, we
Okay,
can.
I'm almost rounding up. I know my time is
All
almost
right.
up. Yeah.
All right.
So
All right.
another way by which we can use Azure Cosmos DB is when we are running on ad hoc environment. Ad hoc is not really a perfect environment, but is like up to, not really. And that
Sorry,
is
Sachet. I think you stopped sharing your screen, your slide.
okay. Sorry, let
Yes.
me stop that. I had a power cut here, so maybe that's
Okay.
why. So let me
Okay. All
reshare
right.
this.
Okay.
Sorry
All
for
right.
that.
All
Yeah,
right.
I'll just reshare my screen. Where is sharing? Sorry, guys. I'll just reshare this.
No issues about that. No issues about that.
Uh, oh, yeah, that's the share. Share this. Okay, I
All right.
minimize
Good.
this.
Yeah.
So,
Good.
okay, this is
Good.
yeah.
Good. All right.
So, sorry, I've moved a slide. I was talking of Cosmos DB. Now, Cosmos DB now take us more into ad hoc environment, like you're running something on IoT. You need to query some data. You need to have a feeder. You need something like a Cosmos DB that can single-handedly, against time, guarantee speed in terms of your use of skill and how your modern app can work. Because when we talk of our today millennial guys, they are not they don't like to waste time. They want something at the at the speed of time. So you need to have something like a Cosmos DB that can help you to do that. Now, for Azure, let's try to look at some behavioral differences in terms of looking at the tables. For Azure's table, it is stored more on non-relational data, which is not structured in the cloud, while Azure Cosmos DB table provide you something for developers out there, an API application that you can write on Azure table storage and ensure to help you to have a dedicated throughput, and it is scalable. Now, in terms of behavior, we know that Azure Cosmos DB capacity can be funny, and in terms of results, it's not really like a regular table. It's limited to a certain number, like 255 bytes, and it's also case sensitive in terms of storage of those tables. This is an example of what Azure Cosmos DB can support, like database like Cassandra, MongoDB, Jamelia, table storage. If you are running through an API, it can help you to have your write-read environment in terms of writing it on Apache. It can also help you to write it on some database that are non-SQL database function. So I think in summary, we are able to look at how we look at relational database. What are the sequence that is tied to relation? And I make example of myself as the fourth generation to other, down to the third to the fourth generation. Each of these data can be multidimensional, and such environment is an SQL database. And we also look at different type of data because that is the norm of today. So I think that is the end of my slide. Now I run back to Promise if there's anything that is worth looking at. Sorry.
All right. Thank you very much, Sashay, for this. I mean, it was a very, very interesting session. I can tell you that I really, really learned a lot. I really, really learned a lot. I mean, talking of SQL, these are things that we basically make use of in every day of our work. So it was actually interesting hearing you give us insight on how to understand some of these features we see in Azure. So like I said, I really really had my notebook and I was jotting and just trying to gain as much as I can. Currently, I see that there are no questions currently. And I mean, this just tells me that our audience was able to understand everything you said for them not to actually have questions about it. And of course, these are the kind of audiences we are looking for. And also, we also welcome audiences that are not so specialized in topics like this, because I mean the idea is to be able to introduce topics like this and shed more light on it. So if we are not having questions today, it doesn't mean we are not going to have questions tomorrow. So I mean, it was such an interesting session. Thank you very much, Asi. It was really really nice having you on this stage and podium today. Thank you.
Thank you for having me. It's a pleasure.
You're welcome. You're welcome. All right. Thank you, everyone. I mean, this has been an interesting session for today, and I'm glad we were all able to participate and enjoy the session. So at this point, I would also like to reiterate: if you haven't followed our channel, if you haven't subscribed to our YouTube channel, if you haven't followed our LinkedIn page, our Twitter page, I'll encourage everyone to actually go ahead and do that, so you can keep updated with our programs for you this year. We are going to be having other sessions also from next week. In fact, tomorrow we are having one very interesting session. We're going to be having an MVP in the house, and it's called the Talk to Series. So if you haven't been to our meetup page, go check out our meetup page, register for the session we are going to be having tomorrow, and prepare, come along with your questions tomorrow. We are going to be talking with one of our experts in the house, Mrs. Foyi, who is also an MVP, and she's going to be talking about how she has carried on her journey and how she has gotten to this stage where she is right now. So prepare to meet her tomorrow. Share, write down your questions, and then we'll be happy to hear from you. At this point in time, I mean, everything they say that has a good start must also have an ending. So this time has come to the end of this session for today, and I would like to say goodbye to everyone. So cheers. Bye bye, everyone.